Alright guys, sorry for whatever reason my video cut out after I had already started this. So we are looking at Monday night's homework, lesson 6. We should have our notes alongside us so that we know what's going on as well. But here we see that Martinstown is building a volleyball court based on a scale drawing that is 40 centimeters by 80 centimeters and uses the scale that for every 1 centimeter in the scale drawing that is 22.5 centimeters in real life. It doesn't say this, but if we use common sense, we know that the drawing is going to be smaller than the actual, so this is tied to the drawing and this is tied to the actual. So if we look in part A, it says write an equation, which is our buzzword, so that's why it's highlighted and we wrote the equation, for the proportional relationship, which is equal to between the drawing court length x, so the drawing is x in centimeters and the court length is y, so this is the actual court is the y. And so you remember it's the equation, we want it in this format, and in order to put it in this format we have to find k. And k, as we know from our buzzwords, is y over x. So if we come back, we could take our scale factor here, okay? And so our scale factor is 1. It represents x because remember x is the drawing, and y represents the actual, so that's 22.5. So if we put y over x, it simplifies to 22.5. So we substitute that into the equation and we end up with y equals 22.5 x as our equation. So now we should be able to use this equation to solve for different lengths and widths. Alright, so here in part B it says, what are the length and width in meters of the actual court? Show your work. Okay, so we need to stop and think for a second. Here, this throws a wrench in our plan, meters, and everything is measured in centimeters. So we need to stop and think about that, but we'll do some converting after. So let's just find the actual length and the actual width. So we know, okay, we're looking for length and we're looking for width. Okay, and so you've got two different options here. You can use the equation, okay, and we're looking for the actual, which is y, so we're looking for y. We know our k is 22.5, and the length, it says, is 40 centimeters. Okay, and so we can put that into our calculator of 22.5 times 40, and we get 900, okay, and that's going to be 900 centimeters, okay, and so that's how we would plug it in using an equation, or looking at the width, okay, we can do a ratio box. Sorry guys, my words aren't working today. So if we're looking at the actual over the drawing, and we use the scale of 22.5 for the actual and 1 for the drawing, and in the drawing, if it's 80 centimeters wide, what is the actual going to be? And we can cross multiply, which is just multiplying that 22.5 times 80, which is exactly what we would have done had we plugged it into the equation. If we had plugged it into the equation, it would have been this. So essentially we're doing the same thing. So we would plug in 22.5 times 80 and we get 1800 centimeters. So that's how you can do either one. You can do the equation or you can do the ratio box. So we've got in centimeters, and actually guys, you know, I'm realizing something. These really need to be swapped around because typically your length is longer than your width. So the 900 centimeters actually goes with the width and the 1800 actually goes with the length. In all actuality, it really doesn't matter, but I just don't want you to get confused when you go to punch your answers in tomorrow. So the 900 goes with the width and the 1800 actually goes with the length. Alright, so anyways, moving on from there. So we need to go from centimeters I'm running out of room here, centimeters to meters. So if we remember the little saying, King Henry died by drinking chocolate milk, okay, then this B is the base, okay, and then we're working with meters, and this C is the centimeters. So we're going 2 hops away. So what that means is there is 100 centimeters for every 1 meter, and which makes sense because like a century means 100 years. So there are 100 centimeters in 1 meter. So if I have 900 centimeters, so let's make this into a ratio box here. Okay, if we're going centimeters to meters, centimeters to meters. If there are 100 centimeters in 1 meter, and I have 900 centimeters, how many meters would that be? So we would cross multiply here, 900 times 1, which is just 900, and then divide it by 100, and we find out that that is 9 centimeters. So our width is 9 centimeters. And we're going to do the same process for the length for our 1800 centimeters. So you should be able to do the same thing, plug it into the ratio box. There's 100 centimeters in every 1 meter. If I have 1800 centimeters, how many meters does that equal out to? And you should be able to solve for that. Part C says write the ratio of the area of the actual court to the area of the court in the scale drawing. So here we're finding area. And you know, a volleyball court, in order to find the area, you have to know what shape are you working with. And so you have to stop and think, well, what's the shape of a volleyball court? The shape of a volleyball court is a rectangle. So if I have my scale drawing, okay, and it is 40 by 80, you know, to find the area, you do area equals length times width. So we would multiply those two things together, and we would get the area for the scale drawing. Then we would do the same exact thing, okay, and it doesn't specify if it wants it in centimeters or meters, so you could use centimeters or the meters, either one, it doesn't matter. You just need to specify which one you used. But if you use the centimeters and the 1800 centimeters, then you would set up your court the same way. You have 1800 centimeters and you have 900 centimeters. Or, like I said, you could set it up once you have changed it. This should say meters. Once you have changed it to meters, you could just multiply it as the meters too. But that's what it's asking. It's looking for the scale drawing and the actual court area. Okay? So you need to make sure that you find the area of both of those. So moving on to number 2. Alright, the students in Roberta's school are painting a mural that will be 8 feet by 15 feet. First, they make a scale drawing of their mural with a scale of 2 feet to 5 feet. Write an equation, ding ding ding, buzzword right there, write an equation, y equals kx, for the proportional relationship between the drawing mural, which is x, so the drawing is x, and the mural length, so the actual mural is y in feet. And so this really is set up the same way as this one up here. Instead of using centimeters, we're using feet. And so we're looking for the equation y equals kx. And we know that x here is the drawing, and y is the actual. So when creating this equation, remember we're trying to find k, just like we did up here. So we need to put y over, because x equals y over, k equals y over x. So we need to put the actual length over the drawing length. So if we look back at our scale that we're given, you know, the actual is going to be bigger than the drawing length. So we've got 5, which is going to be your actual over 2. So your K is 5 halves. And so when we create that equation, we're just going to substitute that in. And you can just write your equation right there. Okay? Part B says, what are the length and width of the scale drawing in feet? Show your work. So we've got the actual here, and we need to know what's the scale drawing. So same thing, same concept here. If we're looking for the length and the width, this time you know the actual and you're looking for the drawing. So you can either use the ratio box or you can use the equation. I probably would say go with the ratio box just to keep things easy, but let's just use the equation for this one, and then I'll let you pick what you want to do for the width. Okay, so we're going to use the equation that we created, y equals 5 halves x. And so the length, remember, is the longer number, so 15. So we need to know 15, is that going to go in for the y or for the x? Well, 15 is the actual, so that's going to plug in for the y. So I've got 15 equals 5 halves x. And so we need to solve for x. And so this goes back to what you did last year. So to solve for x, we want to split, I call it chop it. Okay, we want to chop the equation in half so that we have two different sides. And our goal is to isolate this variable, so I put a box around it. So I know this guy has to stay, but everything not boxed in has to go to the other side. And to go to the other side, we have to use the opposite operation. So I call it chop it, box it, do the opposite. So right now, 5 halves is being multiplied by x. Because anytime a number is touching a variable, it's multiplication, and a fraction is just a number, so they're being multiplied right now. So the opposite is going to be division. So we do 15 divided by 5 halves, and whatever I get as my answer, that's what x is going to equal, and that's what our length is going to be. Now, you can do the same process for the width with 8 feet, or you can use a ratio box like we did up here with the actual versus the drawing. Totally up to you, but I'm going to let you figure out how to do that. Alright, moving on. Number 3. A map has a scale of 1 inch to 10 miles. Find the distance on the map between two cities that lie 147 miles apart. Show your work. So you've got two options here. You've got the option to find K and to create an equation, or in my opinion, the easiest way for this is to do a ratio box. Because what are you comparing? Your scale tells you what you're comparing. You're comparing inches to miles. So inches to miles, inches to miles. So if this is my scale, this one right here is my scale, I go 1 inch is every 10 miles. And if two cities are actually 147 inches apart, how many inches apart would they be on the map? And so you could solve for x that way. And I feel like that's just going to be the easiest way. When in doubt, do the ratio box. I feel like that's the easiest way to do things. Alright, moving on. Number 4. Ricardo draws a scale model of a floor plan of his house. His house is 60 feet long and 40 feet wide. That's important. 60 and 40 feet wide. He uses the scale of 1 inch to 4 feet to draw his model. Which statements are true? Select all that apply. So my scale, I want to write this over here. My scale is 1 inch to 4 feet. Okay. And then his drawing, or his actual house, is 40 by 60. Okay. So here says the equation L equals 1/4 60 can be used to find the length of the scale model. So if we wanted to find the length of the scale model, if we did this, if we took this 1 inch to 4 feet, 1 inch to 4 feet, okay, and we did multiply that by 60, if it gets smaller, then we know we did it correctly, but if it gets bigger, then we didn't do it correctly. So if we have 1/4 times 60, that gives me 15 on the scale model. Well, if you are confused, you could double check it with a ratio box. Okay, so 1 to 4, so we got inches to feet, inches to feet. Okay, so if I have if I know this is 60 inch or 60 feet, how many inches is that going to be? I could cross multiply and divide. 60 divided by 4, and I'm going to get 15. So I get the same answer with both of these, so I know A has to be the correct answer. Alright, and we want to test out some more. So the equation W equals 4 times 40 can be used to find the width of the scale model. Well, you know, the scale model is going to be smaller than the actual, and 40 is the actual. So if I do 4 times 40, I get 160. So logically, can the scale model be bigger than the actual width? And the answer is no, because they didn't use the scale. Okay, so your scale, if you haven't picked up with this, your scale is K, and this is not it. Okay. The width of the scale model is 10 inches. So we could test that out. We want to test it out. We want to make a ratio box here. We've got inches to feet, and if for 1 inch there's 4 feet. And in the real world, if it is 40 feet wide, how many inches is that? And so you should be able to cross multiply and divide to tell whether this is true or not. And then the same thing for the length. The length of the scale model is 240 inches. Well, we've kind of already set up that ratio box here, and we found the answer to that. So is this true? Is it 240 inches based off of the ratio box we've already done? And let you decide that. Alright, the scale means that 1 inch in the model represents 4 feet in the house. So what they're saying is, does it mean that for every 1 inch that we draw, that is actually 4 feet of the house? And I'm going to go ahead and tell you this is a yes. This is true. Okay, that's how we read the scale. That's what we talked about today in class. Alright, number 5. A scale drawing of an elephant shows an animal as 6 inches high and 10.8 inches long. The scale used for the drawing was 3 inches to 5 feet. What are the height and length of the actual elephant? So once again, I would do a ratio box just to keep life easier, where you've got the actual over the scale drawing, the actual over the scale drawing. I'll call it SD for scale drawing. And you have inches to feet, and so we know that the actual is going to be bigger, so 5 to 3. And so we've got height versus length. So it says is 6 inches high. So if we do the height, if we call this one the height, okay, we would plug in that it is 6 inches high. We're looking for the actual, cross multiply and divide. You'll get your answer. Same thing that you would do for long. You would do the ratio box, plug 10.8 in, and get your answer. Okay, that's why I love to use ratio box, because it's pretty easy and pretty straightforward. All right, number 6. Town planners are planning a 50-foot by 500-foot by 700-foot parking lot by making a scale drawing that is 90 inches by 126 inches. What is the scale of inches in the drawing to inches to the actual job? So if you have 500 right here and 700 here, right, and if the scale drawing is 90 to 126. You can pick whichever one. You want to know that your smaller number is going with your smaller number and your bigger number is going with your bigger number, just so that it ends up becoming proportional. And so you want to compare, okay, this is the actual versus the drawing. You want to compare these two, but they want it where the scale drawing is first and the actual is second. So if I have the scale drawing 90 to 500, I could simplify that by creating it into a fraction. Okay, and then I would just simplify that in my calculator to be able to get the proper answer. Alright, so moving on into spiral review. I'm going to run through these super fast because it is a review and this video is getting kind of long. So, a machine produces parts at a steady rate of 160 parts in 8 hours. Complete the table for this relationship. So, you're just plugging in, you're just like solving the parts here. To me, what I would do is like, oh, that's a ratio box. And I would cross multiply and divide. When I got that piece of it, oh, there's a ratio box. I would cross multiply and divide. Then it got that filled in. Oh, cross multiply and divide. And there it is. Okay, that's just what I would do. I would do a bunch of ratio boxes. Alright, number 8 says the table shows possible numbers of basketball team in the league and the number of jerseys needed for the number of teams. Part A says graph the relationship between the number of teams in the league and the number of jerseys needed. So you need to graph these numbers here, the best to your best ability. And it says, is the relationship between the number of teams and the number of jerseys proportional, which means equal. And if you don't remember, you need to look back in your notes, back to 1.5. Or sorry, not 1.5, I think it was 1.4, yeah, 1.4, and we talk about what are the two stipulations that tell you that a graph is proportional. Is it a straight line, and does it pass through the origin? So after you graph those points, you need to tell, is it going to go through the origin, and is it a straight line? And so that's it. All right, that's tonight's homework. Sorry, it kind of got a little wordy there, but hopefully it helped you out.